Hey, so besides turning things into logs, let's see how we can solve some of these exponential equations. Or we're also going to turn things into logs. But okay, so say we have something like 2 to the x equals 4. We already looked at this. We said that if 2 to the x equals 4, x has to equal 2. And I know that because, well, 2 to the 2 equals 4. That one was pretty simple, and we can just kind of look at that and figure it out. We're not always going to be able to do that. So say we have something like 2 to the x plus 2 equals 4. Well, again, I know some things about this. I know that 4 is 2 squared. So I can rewrite this as 2 to the x plus 2 equals 2 squared. Notice I didn't add or subtract or divide or multiply or really do anything to both sides of the equation. All I did was rewrite my 4 so it had the same base as the other side. Well, now they have the same base. If 2 to the x plus 2 equals 2 squared, the 2's are already the same. Do you see that? 2's are already the same, so that part of my equation is actually equal, which means my exponents would have to be the same in order for this to be true. So x plus 2 would have to equal 2. So x would have to equal 0. Can check. Put 0 in. 2 to the 0 plus 2 is 2 squared, which is 4. Okay. Say I got something like 4 to the x minus 3 equals 8. Again, just by looking at it, I'm not sure. 4 to the what gives me 8? I don't know. But I know that I can rewrite them so they have the same base. I know that because 4 can be rewritten as 2 squared. I know a number raised to a power that gives me 4. So I have 2 squared to the x minus 3. And 8 can be rewritten as 2 cubed. Now my bases are the same. And again, what is this operation here? If I have exponents raised to a power, I just multiply, right? So when I drop my exponents, because my exponents are the same, then I can go ahead and just multiply them. Get 2x minus 6 equals 3. So we'll bring it up here. 2x equals 9, and x equals 9 over 2. Okay, let's look at another one. Say I got 3 to the x minus 6 equals 9 to the x. Again, if I look at this, I'm not really sure. 3 squared I know gives me 9, but there's too many x's on both sides. So I'm going to try to get to be the exact same base. 3 to the x minus 6 equals 9 would be 3 squared. 9 was raised to the x, so 3 squared raised to the x. Again, now they got the same base. So since the bases are the same, that means my exponents have to be the same. I can go ahead and drop them and get x minus 6 equals 2x. Solve. X should equal negative 6. What if I have something like 5 to the x plus 2 equals 1 over 25? Well, 25 I know I can rewrite. I would have 5 to the x plus 2 equals 1 over 5 squared. So 25 I knew I could rewrite. 25 is the same thing as 5 squared, but these still aren't common bases. One is in a fraction, one isn't. Before, when we've done this, we have cleared our fractions by multiplying both sides by the common denominator. This time, though, I'm working with exponents. So I'm going to try to use an idea of exponents to get rid of the fraction. Well, I know that there is a type of exponent that flips it over a fraction bar. And that type of exponent would be a negative exponent. So I'm going to write this as 5 to the negative 2. That would bring it up, that would flip it over the fraction bar. So again, my bases are the same, so I'm just going to kind of cross them out, which means x plus 2 has to equal negative 2, and x is going to equal negative 4. Try a last one. 9 to the x minus 3 equals 1 over 27 to the x. So I'm going to kind of do the same thing. 9 I could rewrite as 3 squared, that to the x minus 3. 1 over 27, well, I know I can write 27 as 1 over 3 cubed. That was to the x. And to flip over the fraction bar, it is going to be 3 to the negative 3. That to the x. Okay, so now I got same base. I can drop them. Don't forget that I'm distributing these exponents. So I'll get 2x minus 6 equals negative 3x. So I can solve from here. Negative 6 equals negative 5x. And x equals 6 over 5. These would not be good to try to check by subbing in because they're going to be pretty evil. So just kind of check your work. Make sure you didn't lose a negative somewhere. Okay. So let's look at this one. 5 to the x equals 7. So this is where we started at logs. We said, well, I can't find a number that 5 raised to gives me 7. I tried. I got no clue. And we said, well, I can rewrite it as x equals log base 5 of 7. While this is true, this is pretty useless. If you've looked at a calculator or computer, you've seen logs before. You have seen, and I'll write them up here, you have seen log and you have seen natural log. Those are the only two that really exist on a calculator or computer. You don't have log base 2 or log base 3 or log base 20. So instead, I don't want this as an answer because I couldn't actually plug that in to find a numerical answer. I'm going to want an answer that's written in either log or natural log. Either one is fine. So to do that, I'm going to try to take the log of both sides. Again, I can do anything to an equation as long as I do it to both sides. So let's see, why did I do that? I got log of 5 to the x equals log of 7. And the reason I did that is because one thing we know about logs is that exponent comes down. So this is actually x log of 5 equals log of 7. And now this is pretty easy to solve. I can just divide both sides by log of 5. And I should get x equals log of 7 over log of 5. And now this I could put into a calculator or computer and get a numerical answer. So this is a much better answer. Okay, let's try another one. Say I have 6 to the x plus 2 equals 11. Again, I can't rewrite 6 and 11 so they have a common base. So I'm going to take the log of both sides. And because I'm lazy, I'm going to take the natural log. It's one whole less letter. So natural log is 6 to the x plus 2, and it doesn't matter. Both, either log or natural log, will give you the same answer because you're doing the same thing. As long as you take natural log of both sides or log of both sides, you're fine. So natural log of 6 to the x plus 2 equals natural log of 11. I'm going to bring down my exponent. X plus 2, natural log is 6. X plus 2 whole things be multiplied, so I'm going to use parentheses. Equals natural log of 11. And now from here, I can just divide. I'm going to divide both sides by natural log of 6. On the left side, that's just going to cancel. So I'm going to get natural log of 11 over natural log of 6. Oh, I'm running out of space. I did this wrong. Well, we'll bring the x plus 2 on the other side. Equals x plus 2. And my last thing I'm going to have to do to solve for x is to subtract the 2. So I'm going to get natural log of 11 over natural log of 6 minus 2 equals x. And that's it. Okay, let's try next one. See if I have enough space for it. 3 to the x minus 2 equals 4. Well, I think I'll bring this down here so I'm not crunching up hardcore. So 3 to the x minus 2 equals 4. I'm going to take log or natural log of both sides because, again, I can't think of 3 raised to any power that's going to give me 4. So natural log of 3 to the x minus 2 equals natural log of 4. Bring down x minus 2. So x minus 2, natural log of 3 equals natural log of 4. I'm going to divide both sides by natural log of 3. So x minus 2 equals natural log of 4 over natural log of 3. And x equals, add my 2 to both sides, natural log of 4 over natural log of 3 plus 2. Okay, one thing a lot of people ask is, can they just cancel the natural logs? And I can't. Again, it's an operation. It's not a constant, it's not a number, it's not a variable. It's something that's happening to your things. So you can't just cancel it out. So that's just it. Hey, so let's try the next one. So I get 5 to the x minus 4 equals 8 to the x. So if I look at this one again, I can't think of 5 raised to any power that's going to give me 8. So I'm going to take log or natural log of both sides. I'm going to stick with natural log, but it doesn't matter what you all do. And this time I have 2 exponents I can bring down. I can bring down the x minus 4, and I can bring down the x. So I'll have x minus 4, natural log of 5, again, parentheses to show the whole thing's being multiplied, x natural log of 8. Now I could divide, but I know I need to solve for x. When we solve for x, we need to get all of our x's on one side, everything else on the other. That's what solving for x means. We've been dividing before because it was an easy way. We only had x on one side. This time, because I have x on both sides, I'm not going to divide. I'm going to distribute. I'm going to get x natural log of 5 minus 4 natural log of 5 equals x natural log of 8. Okay, I said I need to get all my x's on one side, so I'm going to subtract x natural log of 5 from both sides. If I do that, I'm going to get minus 4 natural log of 5. On the other side, I can't actually combine them, so I'm going to get x natural log of 8 minus x natural log of 5. As I said, I can't combine these. When we're subtracting logs, we're actually dividing, but we don't want to divide these because our x would have to go back in the exponent, and that'd be going backwards. We were trying to get our x's out of the exponent. So when I can't combine, another thing I've tried is factoring. That's how we solved a lot of things we haven't been able to combine. So see if you can factor anything. In this case, I can. I can factor out an x. So if I factor out an x, I'll get natural log of 8 minus natural log of 5 equals negative 4 natural log of 5. Well, now I can solve this pretty easily. I can just divide by that parentheses, natural log of 8 minus natural log of 5. Do that to both sides. Oh, I don't need a parentheses on the other side, I guess. Minus natural log of 5. On my right side, it will just cancel out. So my x is just going to equal that. Again, don't try to cancel stuff. Natural log of 5 or natural log of 5, I'm not going to be able to cancel since things are being added or subtracted. So just leave it. Once you solve for x in these, don't try to simplify, just leave it. Okay, let's try the next one. 3 to the x minus 2 equals 9 to the x plus 4. Oh, well this time I can write as a common base. I haven't been able to any of the previous ones, but 3 and 9 I can. I can keep my 3 as 3 to the x minus 2. 9 is the same thing as 3 squared. So 3 squared to the x plus 4. Aha! If I got a common base, and I can just cancel them, get x minus 2, don't forget to distribute, equals 2x plus 8. So x equals negative 10. And that's it. So always look for that. If you see that they can be a common base, it will be much easier, plus you'll get a more solid answer. Negative 10 is simpler than log of 9 over log of 3 and so on. Okay, let's try the last one. 4 to the x minus 6 equals 6 to the x minus 1. This time I can't rewrite them as a common base. 4 could break down to 2 squared, but 6 can't. So I'm going to take log of both sides. I'm going to take natural log again. And I'm going to do this so that way I can bring down the exponents. So I'm going to get x minus 6, natural log of 4 equals x minus 1, natural log of 6. Again, I got x on both sides, so I'm going to distribute. X natural log of 4 minus 6 natural log of 4 equals x natural log of 6 minus 1 natural log of 6. I'm going to get my x's to one side and my numbers to the other. So I'm going to subtract x natural log of 6. And at the same time, I'm going to add minus 6 natural log of 4. So I'll get x natural log of 4 minus x natural log of 6 equals, if I add 6 natural log of 4, so 6 natural log of 4 minus natural log of 6. Okay, so again, I can't combine these x terms. So I'm going to factor. I'm going to get x times natural log of 4 minus natural log of 6 equals 6 natural log of 4 minus natural log of 6. And I'm going to divide by that parentheses. So natural log of 4 minus natural log of 6. On the left side is going to cancel. So I'm just going to get x to equal 6 natural log of 4 minus natural log of 6 over natural log of 4 minus natural log of 6. Again, I can't cancel because I'm adding or subtracting things. Don't try to simplify these, just keep it like that. Okay, hopefully that made some sort of sense. And things to look for when you're doing these, see if you can find common bases. So there's two types of these. One's where you can find common bases. If you can find common bases, then find them. So first type is common bases. You find the bases, and then set exponents equal to each other. So cross out bases. So one's like the first type, where 2 to the x equals 4. One that was 4 to the x equals 8. 3 equals 9. 5 equals 1 over 25, 9 equals 1 over 27. I can find common bases for all of those. And again, the 3 equals 9. The other type, is no common bases. There, take the log, or natural log, bring down exponents, and solve. So ones like 2 would be the 5 to the x equals 7, 6 equals 11, 3 equals 4, 5 equals 8, and the 4 equals 6. Those would be all the ones where I can't find common bases. Okay.